Alright, I wanted to do a couple more quick examples on composition of functions. So first of all, compositions, if you remember, are two functions. It's one in terms of another. So one way we can do this is called f of g, where obviously f of x is one function and g of x would be another. Now you can use any two letters you want, but in general we tend to use f of x and g of x. Okay? In this case, we are showing you that f is the outermost function, which means we are going to take our g function and input it into f, and then we're going to simplify. Okay? So here you can see the directions are that you're going to plug your g of x into f of x. Now when we're talking about the domain side of things, for this type, the domain is going to be a little more difficult, again, with your composition for a couple reasons. First of all, we have to take into account the domain of the inside function. So here my inside function is g. So the domain of g could potentially play a part in finding the domain of the composition. Okay? You still have to find the actual composition itself, but you need to make sure that you combine your domain of the inside with your domain of the overall result. Okay? So, as a fast example, what happens if I had two fractions? So you can see here that my f of x is 1 over x minus 2, and g of x is 5 over x. So I want to find f of g. Okay, so f of g says I'm plugging g into my function of f. What that means is that anywhere you see an x, you have to replace it with your g function. Okay, so clearly my function of f was 1 over x minus 2. So I'm going to input g in for that f, or that x value. G was 5 over x. So you can see this becomes 1 over 5 over x minus 2. Now the biggest thing you have to remember is you have to make it pretty. Essentially what that means is you have to do or simplify your fraction so that it actually looks nice and not scary and confusing. To do that, remember your fraction rules that says keep the top and then multiply it by the reciprocal of the bottom. Okay? So here 1 times the reciprocal is going to give you x over 5 minus 2x, and this was my composition. Okay? So this right here is going to actually be your composition. Now, that being said, we need to find the domain. So the first thing you need to do is you need to find your domain of your inside function. Our inside function was g of x, so I need to find the domain for g of x. If you look at g of x, it's 5 over x, which means we have to follow the fraction rules. Fraction rules essentially say you cannot have a 0 in the bottom. Therefore, your 0 in the bottom does not work, so the domain here you can see is all real numbers with the exception of 0, because you can't divide by 0. After that, you have to look at the domain of your composition. So I have to again apply my fraction rule, which says the denominator cannot be 0. Essentially what that means is that we have to solve that 5 minus 2x can't be 0, so we have to solve for the x value that makes that happen. When we do that, you come up with 5 halves. Okay? So if you look at it, subtract 5 divided by negative 2 gives you a positive 5 halves. So the domain of just my composition is all real numbers except 5 halves. Now we have to know the overall domain of the two. So we have to combine them together, which is how you get this bottom. So this piece right here would be the actual domain that you are looking for to this specific composition of functions. Okay? Well, now I want to look at what happens if we did the other. What happens if instead of f of g, we had g of f? Well, here in this way, f becomes the inside function, which means anywhere you have an x in your g of x function, you need to input your f and then resolve. It also means when we're looking at the domain of your f function becomes the important piece instead of the g. So here you can see that we have the same two functions that I had as my other example. Only in this case we're going to do g of f. So here my function g was 5 over x. The x is what gets replaced. It gets replaced with your function of f. So my overall becomes 5 divided by 1 over x minus 2. And again, you need to simplify or make it pretty. Okay. So we're going to simplify this function here. Again, you're going to keep the top and multiply by the reciprocal of the bottom, and that is how we get the overall function. Now the last thing we need to do with that again is your domains. So in this case, we have to start with looking at the domain for your inside, which is the f of x. So the domain for my f is where the denominator again can't be 0. So we are solving that x minus 2 can't be 0. In other words, x can't be 2. So this is how we got the domain for the f value. Now the second part says you need to look at the domain for your composition. Well, here's my composition. If you notice, it's linear. And the one thing we know about domains of linears is that they are all real numbers. Again, you have to use the composition of the two, which as you can see here, you then have to finish out with 2 to positive infinity. Okay? So the biggest thing you need to remember with your domains is that all domains should start from the smallest, most negative, and go to the largest, most positive. The way I like to remember that is that your domains essentially should be traveling along the infinite spectrum in some capacity from negative to positive infinity, depending on the values that you are working with. Okay. So now I wanted to look at another example. Okay, and so here I have that I want to find f of g and g of f and the domains. And I want to use the following functions, that f of x is equal to 2x plus 1 and g of x is equal to the square root of x. Okay. So first thing I want to do is I want to go ahead and do f of g. So f of g says that f is the outermost function and g is the inside. In other words, I have f of g of x, which means I am inputting g into my function. So my function of f was 2x plus 1, so this becomes 2 with a space plus 1. And then we have to look at what is actually going into this space. Well, this is my g function is going to be going into that space. So here this becomes 2 times, and it's the square root of x and plus 1. Obviously we want to simplify, but there's not much we can do. This is just 2 square roots of x plus 1. Okay. Now if I want to look at the domain of that, the first thing I have to consider for my domains, okay, is I have to consider the domain of my inside function. So my inside function was going to be g of x. So the first thing I have to look at is the domain for g of x. So in this instance, g of x is a radical. And the rule of radical says the stuff under the radical must be greater than or equal to 0. So my domain of g is going to be the stuff under the radical, well in this case this is just x, and it has to be greater than or equal to 0. Therefore, we are looking at the domain where we go from 0 to positive infinity. My 0 has a bracket because it is included in its domain. Now the second thing that we have to look at is we have to look at your composite, or the composition. And in this case, we are looking at f of g. That's what we're looking at. So we are looking here at 2 square roots of x plus 1. Well, in this instance, the domain of my composition is again going to have to follow the radical rule, which says that x has to be greater than or equal to 0. Again, this is where we are looking at my 0 being included going to positive infinity. So the overall domain is essentially taking both of them into consideration. Well, in this case, they're the same domain. Therefore, the actual domain of my composition is going to be just as you see it. We are looking specifically at this piece where we're going from 0 to positive infinity, and that is the actual domain, or the overall domain. Okay? Now the second thing that I wanted to do is I wanted to look at doing g of f. Okay? So here, now I want to look at g of f. Well, in this instance, g of f is the same thing as looking at g of f of x. G of f of x says g is on the outermost side, and the f function is now on the inside. So my outermost function was the square root, so it's the square root, and then what goes on the inside? Well, this is where my f is going to go. And the reason for that is because, if you remember, g of x was just simply the square root of x. Okay? So here I have to input my f, which says I now have the square root of 2x plus 1. Okay? So, if you remember, there's nothing else for us to do here, so this is actually our composition. So the second thing we had to do again was look at the domain. So the first thing we got to look at is you have to look at the domain of the inside, which the inside function this time is f of x. Well, f of x here was 2x plus 1. That is a linear function. So the domain of f in this case is going to be all real numbers. Well, all real numbers is negative infinity to positive infinity. That's its domain. Okay. Now the other thing we have to consider now is going to be your composite, which in this case was g of f. My composite was going to be the square root of 2x plus 1. So the domain of my composite, okay, is going to be that the 2x plus 1 has to be greater than or equal to 0. Well, in this case, I have to solve for x, so subtract 1 and divide by 2. So x is greater than or equal to negative 1/2. So that means this one is going to start at the negative 1/2, and it's going to travel up to positive infinity. Okay? So I want the overall domain. Well, my overall domain here again is going to be the combination of the two domains. Okay? Or if you think about it, it's kind of like the overlap. So here, everywhere that we're overlapping is just simply at the composite. So my overall domain is going to go from negative 1/2 to positive infinity. And that is going to be its domain. Okay. So let's look at one more or another example. But in this case, instead of trying to find the domains, here I am asking you to use these two functions given, and in this case I want you to evaluate by them. Okay? So this piece right here tells you what you are going to evaluate by. Okay? In some cases it's just an x, and in some cases it's a number. And so you can see here we've actually got a number. But before we evaluate, we have to run our composition. So I want g of f. So remember, g of f is the same as saying g of f of x. Well, in this case, I want you to evaluate by -2. So there's a couple ways that you can look at it. The first way that we can look at it is finding your composition first and then evaluating. So let's go ahead and do that. To find the composition first says I have to input f into g. My g function is going to be x squared minus 2x minus 6. So here I've got something that I'm going to square minus 2 times something minus 6. And what goes into that something is going to be my f function, and it has to go into both. Okay? So this is actually going to be 4x plus 1 squared minus 2 times the 4x plus 1 minus 6. So I need to solve. This first piece right here, this one, you have to FOIL. Why? Because this is actually a binomial, and a binomial squared means 2 of them. So I'm actually going to have 4x plus 1 times a 4x plus 1. Well, this next binomial, I have to distribute that. So -2 times 4 is a -8. Don't forget your x. And then -2 times 1 is a -2 minus 6. So now I need to FOIL this together, which says first, outer, inner, last. So this is going to be 16x squared. The outer is going to be 4x times 1, which is a 4x. The inner is a 4x times 1, which is 4x. You add those together, so this becomes 8x. And then 1 times 1 is plus 1. Minus an 8x minus 2 minus 6. Okay? So here I've got a 16x squared, so that carries down, so 16x squared. 8x minus 8x is 0, and then I have 1 minus 2 minus 6, which is a -7. So this is going to be 16x squared minus 7. Okay? Now that we've gone this far, the last thing we have to do is we have to evaluate. So the evaluate says wherever you have an x, you have to input -2. So that means this is 16 times -2 squared minus 7. So when you simplify that down, -2 squared is 4. 16 times 4 is 64, minus 7 gives you a 57 as a result. So this would be your overall answer. Okay, so this right here, the 57, would be what we were looking for. Now what I always like to say is if you are evaluating by a number, then a number should be your result. If you evaluate by an expression, then the expression should be your result. Now, I originally said there were 2 ways we could approach this problem. The second way is simply by using the definition. We are looking at g of f of negative 2. So this means that I'm looking at g of, and then my f was 4x plus 1. So this would be 4 times a negative 2 plus 1. So this would be g times, well, 4 times negative 2 is a negative 8, plus 1 is a negative 7. And notice I now have g of negative 7. So that says I now have to plug that in. So this becomes negative 7 squared minus 2 times a negative 7 minus 6. Again, you need to evaluate. Negative 7 times negative 7 is a 49. Negative 2 times negative 7 is a positive 14. And then we have minus 6. So if we look at all of that, that simplifies down to 57. So what do you notice? These are the exact same results. So whether you like to find your composition first and then input your value, or you want to input your value, it's completely your choice, but there are the two ways to attack it. Okay. Now, if you notice, we had another example that said we wanted to take these two functions, but this time we want to do f of g, and we want to evaluate it 1/2. Okay? So, to look at f of g, again, f of g is the same as f of g of 1/2. And so, if you were to use, say, just the evaluation, that would tell us that we are going to have f of, and our g function would be input of 1/2. So this would be my 1/2 squared minus 2 times the 1/2 minus 6. So here we're going to be working a little bit with our fractions. Okay, so let's look at that. 1/2 squared means square the top, square the bottom. So this becomes 1/4. Negative 2 times 1/2, if you notice my 2's will cancel, leaves me with negative 1, and then I have a minus 6. Okay? So here you would simplify that down. And if you think about it, remember, in order to work with fractions, you need a common denominator. So this is my 1/4. In order to turn 1 into something over 4 means I have to multiply, so this is going to be minus 4 over 4. And then again, I have to turn 6 into something over 4, so again you're going to multiply, so this is going to be 24 over 4. Once you do that, you're going to basically subtract across the top and keep the bottom, so this is going to be 1 minus 4 minus 24, which gives you a negative 27 over 4. And that is going to be input into your f function. So now, remember, this was going to be 4 of my stuff plus 1. Well, my stuff here is the negative 27 over 4. So in this instance, if you look at it, 4 and 4 is going to cancel. This leaves me with negative 27 plus 1, which gives you a negative 26 as a result. Now you can check your work by finding the composites and then plugging 1/2 in, and you should get the exact same result. Okay? So if you have any other questions about composites, please let me know. Otherwise, see you next time.